Uh, uh, Hello, this is my English speaking practice. And give me a sec. Okay, and so I'm going to solve a lead code, and yes, but I want to try something new from today. It is it is uh it is to try new editor called NBeam. So, mm, yeah. So until now, I have used VS Code for development, and this is like this. So, oh, yeah. Um, but I want to use NBeam because how do I say? I want to use NBeam because I have a lot of opportunities to use to operate something in the server. So in that case, I cannot use VS Code like this. So I needed to edit text without VS Code. So I needed to get used to use this editor. So I started to learn how to use NBeam 3 days ago. So the difference is like this. So basically I don't use mouse cursor. I use keyboard for movement. And yeah. So until I get used to it, it's a very inconvenient. But if I get used to it, it will be very convenient, I think. So there are a lot of shortcuts like this. So from today, I want to use this editor. And yeah. So for training, I want to solve problems, coding problems. So today's problem is remove duplicate letters. Is this small? Okay. Let's get started. Remove duplicate letters. Given a string S, remove duplicate letters so that every letter appears once and only once. Once and only once. You must make sure your result is the smallest in lexicographical order among all possible results. Given a string S, remove duplicate letters so that every letter appears once and only once. You must make sure your result is the smallest in lexicographical order among all possible results. So let's take out example 1. Input is BC, ABC. So there are 2 B's and 2 C's and 1 A. So the answer is ABC. We have to remove B and C. And example 2, the input is CBA, CDC, BC. So have to remove there are 3 C's, 2 B's, 4 C's and 2 B's and 1 A and 1 D. And in that case, I see. So in this case, there are 4 C's, so we have 3 patterns to remove C's, right? So which C should we leave it? So there is a condition like the smallest in lexicographical order. So we have to check all possible patterns. Yeah. Okay. So in this case, A and D are fixed because they appear only once, and in order to make it the smallest in lexicographical order, this C is so important because if I leave this C, the C is the head of the string, so it's not smallest, right? And if I leave this C, the result would be like ADC, but it's not smallest compared with ACB because C is smaller than the D. So we can find out this C should be left as the answer. Okay. So how to solve this problem? This is difficult. Let me solve this problem Python. So this is a simple case. In this case, we have 2 B's and 2 C's, so we have 4 combinations, 4 possible combinations. And basically we should check all possibilities, and then we have to choose the smallest one. Okay, I will. Can I use NBeam? Right. like this. Hmm. Hmm. I have no idea about this. So basically the larger character should be at later, should be placed later, and the smaller character should be placed earlier. BC. So we need to find out the duplicates at first. I have no idea. So let's Okay, so let's have the index. So for example, B appears at 0 and 0, 1, 2, 3, and C appears at 1 and 4. Okay. A appears at 2. right? And then we need to decide which one should be left. So in this case, how do I decide it? BC. Okay. Let me see another example. In this case, we have A, B, C, and D. A is at 2, B is at 1, and 2, 3, 4, 5, 6. And C is 0, 1, 2, 3, 4, 5, and 7. And D 0, 1, 2, 3, 4. Right? Okay. And then we loop over this hash map, and we can get the key and value. And if the value is the only one, we can fix it. And if the values are multiple, there are multiple options, we need to decide. And at the time, we already decide the smaller the order of the smaller character. In this case, the A is placed at the index 2. So when we decide the place of B, the B should be, we can find out B should be later than A. So so in this case, the 6 is selected, right? And for C, for C, C is placed at 7 since B is already placed at 6, because C should be later than B. So we can find out C is placed at 7. And for D, there are only one. Oh wait, this is wrong. Smaller one. Let me think about it. There are A and ACDB. Okay. Three, four. How do I find out? A B C A B C. In this case, at first we fix the A and D because there are only one candidate, and in this case, we can put something between A and D, so yeah, it contributes to make it smaller. So in this case, there is a C at index 3, so we have to choose the C at the index 3. But this algorithm is something complicated. It seems not to work always not work, I think. So maybe we have to check all possibilities, or C D. For example, let's change E, right? In this case, wait, you have two options. And we have informations like this, and for the first loop we can fix it A and D. And we want to make it smaller. So A and D. So in order to make it smaller, if there is a character smaller than A, we should put it before the A, right? But there is the S consists of lower English letters, so A is a smaller one. So if we can decide the A's place, we don't need to think about before A. So in this case, the index 2 is the starting point, right? And we take a look at next character, which is D, at index 4. So in this case, we have options to put a new character at the index 3. So we have to find the character at the index 3. So maybe we have to another hash map like index to character, right? Index to character. So yeah, when we look at the character at index 3, we can get the E. And we have to compare it. Compare AED and AAD, right? And in this case, AD is smaller than AE, so we don't use it. Right? So maybe we can remove it. Yeah, because this procedure is deterministic, so because we are looking from starting point, so in order to make it smallest, we have to look at from smaller side. So A is fixed and D is fixed, and when we look at the character at the index 3, that is E, and using E at the index 3 doesn't contribute to make it smaller strings, smaller results, right? So we can find out the E at the index 3 are not used, so we can remove the possibility. So at this point, the E has only one position, so we can fix it, right? Yeah. And we already look at until index 4, right? So we have to go next. Yeah, at the index, the character at the index 5 is C, so we have to find out, we have to decide if we use the character or not. But this is difficult. This is a little bit complicated because at this point we cannot decide if we use it or not, because there is a B at the index 6. So so in at this point, AD is fixed and E is also fixed, and we are going to add a C at the index 5, but there is B here. So we cannot fix the C at this point, right? ADC, ADB. Yeah, ADB is the best. So maybe we have to explore some possibilities like this. So we, at this point, the character C at index 5 is not bad, so this is one candidate, but it's not fixed, right? And ADB. Yeah, and then how do I explore some possibilities? C. AEDC. Okay, let me try another approach. I don't use these operations. So today's problem is difficult, so I will focus on the problem. Oh wait, how to like this and copy and paste. Okay, let me try another approach. Yes. So I found out, I feel like, yeah, we have to explore some possibilities, so it's complicated. So we have used some data structure. AC, ABC. So for example, we have to look at from start and C, B, A, E, D, and this is the smallest string until now, because each character appears only once, so we cannot remove character at all, right? And when we get C at this point, oh, there is a C. Oh, there is a C, and we have to decide which one we should use, right? First one or second one. And in this case, this is better because B is smaller than C, right? Yeah. So at the point here, this string is the smallest character. And when we look at B here, AEDCB, right? AEDCB, right? And when we look at C here, AEDBC, yeah, this is smaller, right? And when we look at E here, ADBCE, yeah, this is smallest. This is smallest string as a result. And C, B, A, and C here. C here. But I want to try this. This is a case C, E, A, C. When we meet the C, compare this one and this one, but C is smaller than E, so the first one is smaller at this point. But we have we have two possibilities at this time, because when we move on to the next, E, A, C, D, 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 D. D is only one. D is only one. So for example, we update both of them and look at C. Met C. A, C, D, A, C, D. So this one, this is smaller. Okay. Let me think. EADC is one of the answer. But this possibility is still remaining, right? CEAD, EADC, EACD, EA. I see. this possibility doesn't exist because this is smaller. So so there is a pattern. We can fix the character, or we have to explore some possibilities. What is the difference? Let me see. So next to be and another C. This is enough. So this C doesn't used. And when we meet this E, this possibility becomes ACDBE, and this is the answer, right? And this possibility becomes CADBE. So final answer is this one, right? Let me simulate one more time. C is used, E is used, A is used, and C comes here, and so at this point we have to decide this C is used or not, or we cannot decide it. EAC. So EAC CEA, we have two possibilities. Yeah. At the end, this one is the answer, but at this point this one is smaller, because we cannot we cannot predict the next characters. And and look at D. and look at C. Look at C. At this point, we can fix it in this case because C appears before the D, so we can fix it. I want to define the subproblem. So let me string I is defined as the smallest the candidates smallest string until index I. So string is the array. Strings is the array, and storing うんうんうん。We have candidates. Candidates. Candidates and the character map. Hmm. So if C in CharMap or else, if this is true, we have already the character in the candidates. So how do I otherwise otherwise we can I forget the syntax of Python, so in this case we want to access all of the candidates I and put a new character C, right? Yeah, this is what I wanted to do. And this is important. If it's already contained in the candidate strings, we need to check. Yeah, we need to check. Oh, wait. Huh? I'm confused. Ah, I see. Hmm. Yeah. Access. Access a character like this and this approach is close, I think. But how to the candidate other way some rest no. Charm up C is I, right? Charm up C is I. Alt I. It's like this, and we have to compare them, and I'm stuck. I'm stuck. But I'm getting close. So want to solve. Smallest string until So, let me see. EACD and candidate CAD, right? At this point, and when we at this point, when we look at this C, this is still remain. This is also still remain. Oh, okay, I see. So my question is, this could be like this, but this is same. Yeah, this is a problem. What should I based on when we look at the C? EACD, CEA. Yeah. So we have to we always have two options, right? This so one, two, and three. But this one is obviously larger than this one, so we can remove this. Why this is obvious? Why I thought this is obvious? Obviously larger. Because D might be, yeah, D might be removed after this process. So this option also remains at this point. DC, BCE. Okay, let me do some tests. So next B. Next B. Right, next B, right? And next C. So I see. So there is 4 C's, so there we have 4 options like this. Right. Yeah. In this case, we don't have D anymore, but if I have D here, this option is gonna be the best because A, B, C, D. It would be like A, B, C, D. Yeah, right? So so this approach is correct. But wait. Oh? It's exponential. It's exponential. Not good. Let me see when we get E here. Hmm. I forget. The explanation. We can. We take the head of the remaining, which is a single character, and we have current string. Current strings. Maybe. Oh. I forgot everything. Remaining. So. I gave up. I forget everything. Let's ask ChatGPT and yep. You must preserve relative order of characters. You are deleting characters, not rearranging. Your approach tries to track multiple possible partial results. This explores combinatorially. Yeah, I think so. The key insight is at every position there is only one correct greedy choice if you maintain the right invariant. Really? So instead of tracking many candidates, we maintain one stack and make local decisions that are globally correct. Really? I couldn't come up with greedy solution. If the current character C is smaller than the last character in our result, I see. Maybe I see. So let me simulate CEA. When we look at C, C, D, I didn't see. If the current character C is smaller than the last character in our result, and the last character will appear again later, then we should remove the last character. Push C. C appears later. How to know that? Last index where each character appears. So if C is in stack, we skip the process. If there is a stack and the last element is greater than the C, and the index is stack is removed. Stack removed. Why this works? The stack is always the smallest lexical prefix possible using characters seen so far, while still allowing completion. The while condition guarantees the lexicographical improvement. Feasibility. We can re-add popped characters later. This makes the greedy choice. We optimal mental model. Think of the stack as I want my result to look as small as possible as early as possible, but I'm allowed to undo decisions only if I can recover later. Let me understand. Character and stack, and the state of the final stack is the answer. Okay, so C, push C, and when we look at B, we can remove the C because we can guarantee C appears later, so we should put the B into the stack because B is smaller than the C. Yay, yay, yay. So this is same, so stack gonna be A, and in this case we just push the C, just push the D, and C is already in the stack. This is the difference between second C and third C. second C, in that case, C is not in the stack, but the third C, second C is already fixed, so we can skip it. And B, yeah, so in this case B is less than the D, so we want to remove the D and then we want to put the B to the stack, but D doesn't appear later, so we cannot do that, so just push B, and this is the answer. Right, that makes sense. Let me try it. So first we have to in indices we have to build indices map, like I'm not I forget I forget everything. Enumulate. No, enumulate. Huh? Enumerate. And indices C. Otherwise, this is it. So last store the latest for each characters, and stack for CNS. Oh, I see in enumulate. And skip it. Otherwise we want to compare it with existing characters in the stack. So while loop last character is, we can access like stack -1, but before do that we have to check if not stack if stack is empty, if stack is if stack is if stack we get the last character and last character C is smaller and yeah, C is smaller and C is smaller and that character appears later, we can pop it. Yeah. Is this used? I don't think this is used. So update the stack and append a new one. Otherwise, yeah, just append it. So we can do it like this. That's it. Let me see. Index out of range. Stack -1, but why? -1. We have to check the lengths. Where it is? Stack -1. We can get the last character. I see. Stack and because loop here, so have to check every time, every loop. So like this. Oh, great. Yeah. That's it. Is there any edge cases? Nothing. Yeah, maybe this is correct. Great. Yeah, so let me wrap it up. Yeah. In this program, we have string, and every letter appears once and only once. So we loop over the string, and for each characters we want to decide if we use it or not. And how do I decide? How do I decide? So before asking ChatGPT, I tried to explore some possibilities, but it's not good. Because there are a lot of possibilities and it's exponential. Yes. So in this problem there is a greedy algorithm. So it's like we can find out the character is used or not in locally, and it contributes to the globally optimal, right? It's called a greedy algorithm. So in this case, we can use stack data structure, and the characters in the stack are fixed, so basically fixed. So we return the characters in the stack. That is the answer. But there is a case where we can remove the character from the stack. So when we meet a new character and the character is smaller than the existing characters, at the time we want to use the smaller character because it contributes to the smallest strings in lexicographical order, right? So this part is for that. But I didn't come up with this idea. We should look at from the end. Yeah, this is a difficult part for me. I didn't come up with this. But yeah, it makes sense because by storing the latest index for each characters, we can check if the character appears later or not. So if the character appears later, we can remove the character in the stack. So yeah, we can update the smaller and smaller, right? That makes sense. That's it. That's it. This is good problem. So I wanted to solve this by myself. Yeah, so I feel like I want to solve coding problems every day. Yeah, that's all. Thank you for watching. Bye.